you send something in. The best way is to send 1 amp current into this system and see how it responds. And from how it responds, we figure out what the internal resistance is. Okay, let's solve this problem with this current source in here now. Okay, so I will see that the voltage will develop, and I have a 2 ohm resistor over here. Okay, I would have that I, the test current is 1 amp, and it's equal to V over 2. Okay, the current that flows in this direction, that is V over 2. Okay, that is the current. And then plus Ix. Plus Ix, because the current that flows here, okay, that current is Ix. This current has to be Ix. Okay, this is just applying Kirchhoff current law at this node over there. Okay, so I get the fact that Ix is also equal to V minus 2Ix over 1. The voltage at this point over here, the voltage there is V minus 2Ix, because this is the dependent voltage source. If I take this voltage minus this voltage source, I get the voltage at this point. And that voltage source divided by this 1 ohm resistor gives me Ix. Okay? And from these two equations, I can solve for Ix. And from them, I solve for Ix. Okay, this equation together with this equation, I get the fact that Ix is equal to V over 3. Okay? But also know that the I that I inject in this circuit I, okay, I must be equal to V over 2 plus V over 3. Okay? It's just the current flowing through this branch plus the current flowing through that branch, which is Ix, which is V over 3. This is just Ix. Okay? So, I know what V over I is now. V over I will just give me the impedance looking in that direction. So you can actually look at V over I. V over I, which is half plus 1/3, right? Let me see. This would be giving me 5 over 6. 5 over 6. And then R Thevenin is just the opposite of this. This is 1 over R Thevenin. So R Thevenin is going to be
V over I is 6 by 5.
What is that?
It's 6 by 5, not 5 by 6.
What?
V over I is equal to 6 by 5.
Oh, okay. Okay, it should be I over V, right?
Yeah. I over V is 5 by 6.
In my note, I would have 5 over 6V. V over I is, yeah, this should be I over V, that's right. I over V. Right, you divide this equation by V, you get that equation, and you combine that equation, you get 5 over 6. Okay? R Thevenin is just V over I in this test signal method. You try to look for the resistance looking that way. When you turn off all the current source, so you put 1 M in there, you get R sub T is equal to 6 over 5, it's 1.2 ohm. Just exactly as what they found using this other method.
Okay.
Okay, just exactly as what they found using that method. Are there any questions so far? Okay, so there are always two methods of finding RT. One is from VT and IN, the other one is to look into the input impedance. In the case of a passive network, it's quite easy. But in the case of a source-dependent network, you have to actually send in a test signal. Yes?
V Thevenin and the one that's dependent source example, is that supposed to be 0.24?
0.24?
Yes.
Yeah.
Which one? Which one is 0.24?
1.2 by 5.
Right there.
1.2 divided by 5 is wrong.
It's 0.24.
Make that point.
Let me see what I have in my notes. It's actually 12 over 5. That's what I have in my notes. Okay, 12 over 5. Not 1.2 over 5. It's 2.4. Okay, 12 over 5. If you work this out, it'll be 12 over 5. Okay, maybe I don't need to work it out. You can work it out yourself. You work through the algebra, you'll see that it's 12 over 5. Okay, if you don't believe me, go home and work it out. Because I want to use the last few minutes to do one last example. Okay, let's do one last example. This example is kind of interesting. 2.1.8, sorry. Example 218. And this gives you something that looks like this, a dependent current source, Vx, and then this is Vx. This is 2 ohms, and this is 1 ohm, and then I have something hooked over here. Okay. Actually, this is just a text signal. This one is a text signal. Okay, actually, I'm interested in what this equivalent circuit is looking that way. So, since this has dependent sources, I would like to use a test signal method to find RT. Okay? And if I were to not have any test signal, this circuit does not have any internal sources. So its Vt must be 0. Its In must also be 0, because if I don't have any sources, just look at the circuit itself. It has no internal sources. Okay? But let me find out what RT is by using the test signal method. Okay, the test signal method. And then I find that if I send in 1 amp, I find that V over 3, which is the voltage across V, let me call this voltage over here V. Okay, this voltage over here V. This voltage across here V. Okay, V over 3 must be Vx plus 1. Okay. Okay, let me say that the voltage drop from here to here is V, or the voltage drop from here is V to V. The voltage drop across the 1 ohm resistor will be V over 3. Does everybody agree? Okay, V over 3 is the drop against the 1 ohm resistor. V over 3 divided by 1 ohm will be the current flowing in that direction. Okay, that current flowing in that direction must be the current flowing in that direction plus 1 amp. Okay, that is applying KCL at this node. Okay, so immediately I get Vx is equal to 2/3 V. Okay, Vx is equal to 2/3 V. And then if I work further, I find that this Vx plus V must be equal to Vx over 3 let me see. V is equal to V over 3 plus Vx. Okay, did I get the same equation or not? No. I'm sorry about this. This equation is applying KCL at that node. This equation is just applying a voltage divider. Okay? Vx is just 2/3 of V by a voltage divider formula. Okay, so this is from voltage divider. Now I have two equations and two unknowns I solve. When I solve for them, I get that V is equal to minus 3 volts. 3 volts. Okay, that's what I get. Then R Thevenin will be just V over I in this test signal method over here. Okay, I will get minus 3 ohms. V is minus 3 volts. I is equal to 1 amp. Okay, so I get minus 3 ohms. So I get a negative resistance. It's an interesting example. Why do I get a negative resistance? Negative resistance means that the circuit is active. Okay, it's not a passive circuit. That means that if you look at the power is IV. And if I say that V is I over R, or IR, okay, IR. V is IR in a resistive circuit, this is I squared R. So if R is negative, the resistor is not absorptive, but it gives out power. That's what is negative resistance. So what it means is that this circuit actually can give out power, but it is a dependent current source. There's some very fancy gadgetry behind this thing. You never see it. Everything is just within the black box. But within black box, there are lots of other electronics going on. We don't show it to you. We just tell you that it's a dependent current source. And because of that fancy electronic gadgetry and wizardry, okay, you get the negative resistance out of this thing. Okay? Are there any questions before we end? Okay, if you're happy with this, then you can go home and try your homework.